This is question one. I'm going to show you the code, compiling it. I'm going to run it and also verify the file size matches what ls-1 reports. So without further ado, let's get right into it. Okay, so this is the code right here. Here's my program for question one. The goal is to use exactly one lseek to get the file size of a file and print it. So obviously we have the include over here, include section. I'm going to be using the system call headers fcntl.h and u, and I'm going to be using all of these basically for open, lseek, and enclose, plus studio.h for printing and lib.h arrow for safety. Okay, so the main signature and argument check is I expect one argument, the path to the file. If it's missing, I print a usage message and exit. Then we have the open call. I open the file read only. If open fails, I then the system it's gonna show the error using pair and exit. I just want to make sure that I just want to note that I'm not passing a mode here because like it's not creating a file here. And then right after that, we have the lseek line. This line is one and only lseek. Basically has 0 bytes from the end because it has the seek end right here. And the return value is the byte offset from the beginning. That's the file size in bytes. And then I have the printf line. I print the size. I cast to long for portable formatting with the 11D. And then obviously at the end of it, I have the close FD. This is going to close the file descriptor before exiting, and I check for errors along the way. If lseek or open fails, then I report it and quit. So that can that covers the code: single lseek, correct argument handling, error checking, and a clean output. Now what I'm gonna do is I'm gonna be compiling that code. Compiled, and then we're just gonna run the code here. Okay, so we have the answer as 6728. This runs my program on the source file itself. I print a single number, which is the size of the file number in bytes. In my case, it's a number 678, and then sorry, and then ls minus, and then I want to verify this with ls-1. And then, yeah, AAQ1 is shown again. It shows the exact same file, which matches exactly that what my program printed. So that basically confirms my lseek result is correct. And to summarize this whole assignment, the assignment, like the question one, is that the key points the assignment asked for was I use a system calls open lseek once, and then I use close not standard IO to compute the file size. I performed exactly one lseek, FD0 seek n to get the size. I printed the size in bytes and I verified it matches ls-1. And yeah, that basically is my question one. So I'm moving into question two. I'll show my code, I'll compile it, and then I'll run it. And then I'll run it to create the list one, obviously, the text one, and then use more OD minus C and XXD to inspect the file exactly as the assignment has told us to. Okay, so this is the code right here. So the top includes I'm using a system level IO, FCNTL, and unlisted for open and write. Plus, I'm using the string.h for string length, and then I'm using the studio dot h and the start lib like usual for errors. And then right off the bat, I have for the first two lines over here, I have the payload string. This is the exact text I need to write to list one text. There are the three spaces after the first number in tabs, /t between columns 2, 3, and 3, 4. Each line ends with a new line with /n. And then we have the two lines right here, the 1011, 1024, GM, and forward. So I just want to make sure that you notice that after 1011, there are three spaces, and after GM, there's a tab. After Buick, there's a tab, then 2014, and a new line. The second line mirrors that pattern. And then we have the open call. I create a truncate list1.text for writing with permission 0644. And then the single write, it highlights the important, because assignment says to call write exactly once. And then I build the entire text up front and write it on one call. And then I have the errors check and close here. Check for errors on open and write, and I close the file at the end. So that's the full program system IO only. Exact spacing and tabs. And then a single write, obviously. And I'll compile it from here. A writer dot c slash o, not a zero. Okay, let's compile it. Now let's run this. Okay, after that, so this is gonna create overwrites the file list one .txt that we had in the directory. So as you can see, the list1.txt text is there. And then to show this in plain text, I'll just run this. Okay, so this is the human readable content. You can see the three spaces after the first column, and then the columns after they are separated by tabs. And then I'm gonna quit this. Okay, and then to expect the characters, we shall. And then we have the what's it called? We have the OD minus C shows the character representations of each byte. So spaces show up as actual blank characters. The tabs show up as slash T. In the new lines, show up as slash N at the end of each line. And then I'll inspect bytes with them. Okay, I'll just inspect TXT. Work. Okay, yeah, perfect. So then XXD shows the hex dump, the actual byte values. Space is byte 0 times 20 because I use three spaces after the first number. So you'll see 320 bytes there. Then a tab is 0 times 90. You'll see 0 and 9 between column 2 and 3, and again between column 3 and 4. And then a new line is 0 times 0, A at the end of each line. Together, obviously, OD minus C and XXD confirm the internal layout. They exactly have three spaces which are required in the tabs between like the later columns. So just to summarize this whole question number two. So again, the file is list1.txt and it contains exactly two lines specified. I use a system IO and called write exactly once as the assignment mentioned. I verified the output with more than use OD minus C to see character shapes like slash T and slash N, and then I use XXD to see the raw bytes. And then yeah, so this is question number three. Running it right here. Again, the same stop that I've been using the headers for the rest of them. I already mentioned what to use for, so I'm not going to go over them again. So right off the bat, we have the argument check right here. This program expects exactly one file name argument. If I don't provide it, it prints a useless message. And then we do have the open call over here. I open the file in a read-only mode. If it fails, I call period to explain why. And then I have the read loop. The read loop is basically, this is the core. I read the file into buffer using system call, read, and then I scan through the buffer counting slash and characters. And then we have the line counting variables like line saw underscore any last. I track whether I saw any characters and what the last character was. That way, if the file doesn't end with a new line, I still count the last line. Without this, if I'm missing a file like slash n, it would be undercounted. And the final check I have here is if saw. That's the final fix. If the last character isn't a new line, but I read something, I increment the line and it just counts one more time. And then we have the print result at the end of this. Just prints the number of lines as a single integer. So now I'm going to start off by compiling it. Okay, we have that, and then so I just compiled with GCC. Obviously, there's no error, so it's ready to run. So then I'm run it with the echo. Just takes a second. Okay, this makes a quick test file with the name q.txt with the three lines, and then now we can actually run the program. Perfect. Okay, so the program outputs 3, which matches the number of lines in q.txt, the text file that we had made it, and then, yeah, so here I then created like a file, okay? So that's basically it for this one. To wrap it up, I use system calls only, open, read, close, process file, I counted on slash n, um, and then the characters to get the number of lines. Then I fix the final edges where a file doesn't end with a new line, and then the output matches the actual number of lines in test file, which was obviously 3. And then just to demonstrate the edge case, so the no trailing line on this one, I'm just going to do the echo other command. Yeah, so we got one there. So I basically create a file with one line but no trailing, which was a slash n. So the program still prints one because the final check I added. That basically proves that it's handling the edge case correctly on this one. So that's it for question number 3. All right, so moving on to question 4. Let's put it right away. We got the code right here. So again, includes. I'm not gonna get into that. Main argument check if argc is not equal to 2. I expect exactly one file name argument. If it's missing, I print usage and then exit, and then open with studio instead of open. I'm using f open in read mode. So if it fails, I use pair and exit, and then I'm counting the loop with studio. Here's the core. I read one character at a time. So by reading one character at a time, with f get c, and I count a line whenever I see like slash n, and then I have the edge case handling over here. Where basically I also handle the classic edge case. Like if the line doesn't end with the slash n, I still count it. That's what this last character check is doing over here. And then obviously we have the print at the end, and that basically is going to print the total number of line as a single integer. Now I'm going to get to running this. Okay, so compiled with no errors. And then we need to do that. Go to create file. Okay, so this creates a q.txt with 3 lines text, and then we're going to run with 3 file. Yeah, 3. Okay. So this program prints 3, which matches the number of lines in the file. And then I can also demonstrate the no new line edge case in this one as well. This was similar to the assignment, I mean, the question right before this. Okay. Okay, so we got one there. So has a single. So we know that q.text has a single line without a trailing new line character. So the program still prints one because of that. The final check, so it handles both cases correctly. Now to just summarize this whole question number 4, I use a standard IO f open fjc f close to read the file account lines by using slash n characters. I also handle the case where the file doesn't end with a new line, so the last line isn't missed, and that basically completes question number 4. Moving on to question 5 right here. What this question really wants to do is, it's going to show the contents of a file, ask me to type some text, appends that text using system calls to append, and then shows the file again. So then we have the code right here. At the top, we want to include it anyways. I've been over this. Then we have the helper show underscore file. So what the show underscore file really does is the function moves the file pointer to the beginning with lc, and then uses read and write in the loop to print the file to the screen. That's how I display the before and after. Then we have the helper write underscore all command. What this command really does is it helps make sure my text is fully written. Even if the system only writes part of it, it loops until everything is done. And then we have inside main, we have the usage check. Here, I check for one argument, the file name. Without it, the program prints usage instructions. And then I have the open and show before. I open the file with WR, and then I OCR8 and call show file to print the content before appending. Get the user input, I ask the user to type something with fgets, then I make sure it ends with the new line so the file stays formatted. We have append as well. Append, that's the key part of this whole question. So then I reopen the file using append. The flag ensures whatever I write gets added at the end of the file, not overwriting anything. Then I use write underscore all to append a new text. Finally, I print a header and call show underscore file again to display the updated file. So now let's compile this. Okay, so it compiled with no errors clearly. Now we're going to continue doing this. Oops. So here it shows a file before. Now I type in a new line of text. So for example, and now you can see that. So what I'll do is I'll actually type hello. Okay, so it has the after from question 5, and now you can see the after with my new line successfully appended to the bottom of the file line. So basically, to wrap up question number 5, it was this again system use IO. It shows a file before and after, and append user input using O append. So data always goes to the end, and then I use helpers function to make the reading and writing more uh robust in that one. So that completes question number 5. I'm gonna hop into question number 6 right here. We have it right here. Okay, so this includes the bottom top and then helper show underscore file. This function rewinds to start with the fseek, fp 0 seek set, then uses fgets, and then uses and also use fputs to print to the file screen. That's how I display the before and the after. Main argument, it checks like question 5. I take one file name argument, open file with a plus f open. This whole command opens a file for reading and appending. In this mode, writes always go to the end. That's the studio analog of zero append. Show before I call show underscore files. That underscore file fp to display the current content, and then I prompt and read user input by I prompt like I go then use like the fgets line of size of line sdn to read a line from the keyboard, and then after that normalize new line and append. If the user didn't press enter, I ensure a new line so the file stays neat, and then I fseek fp0 like mentioned in this code. And then obviously I'm not necessarily strict with the a plus, but explicit. But f puts line to append I f lush fp to ensure it's written, and then after that I rewind and call show underscore file again so you can see the updated content. Then after f close fp. So question 5 basically used open read and write and then opened. Question 6 actually uses f open, f gets, and f puts, and mode a plus for appending. So what we'll do is now I'll just compile this. Oh, oops, I did not do that properly. Sorry. Okay, it's compiled. So this creates list one.txt with 2 lines. That as well. Yeah, so we have it here, and then I can basically it prints the file before, then prompts me for input, and then I can put anything, enter text to and I can put anything here. I'll just do uh, 6. Okay, now I append my line using standard IO and shows after the view, where my line appears at the end. And then, so basically, to summarize question 6, same, I use standard IO, f open, f seek, f gets, f puts, f flush, open with a plus, so writes go to the end, append, display the file before and after to verify the change. Then I completed this question on this one. Last and final question, question number 7. I'm recreating the textbook example of making a sparse file. So basically, a file with the whole using the standard I/O. I'll show my code, compile it, run it, and then verify the file's apparent size. That is larger than the disk blocks used. So let's get right into it. So obviously, I have the top, and then I have the open file. Point to fopen whole.txt. So I open whole.txt in a binary read right with WB plus. If it doesn't exist, then it's created. Then I first write left block point to FW right. I write 10 bytes, like A, B, C, D, E, F, G, H, I, J at the beginning. And then I create the whole. Here's a key line I call fseek, where I call fseek right here. This key line basically forwarded by 16 KB without writing. That leaves a gap, so the OS records the region as zeros, but doesn't like allocate blocks for it. And then after that, the second right block, f write. I write another 10 bytes over here, A, B, C, D, F, G, H, I, J, if after with caps, after the gap, and then I close, I close the file to flush everything in it. So with the standard IO, it writes 10 bytes, and then fseek forward, write 10 bytes. The middle is a hole. So now let's actually compile this. Okay, so that creates basically a hole there, the whole dot text with two 10 byte blocks separated by a large sparse region again. So then I'm going to verify it's sparse. Okay, so ls minus ls, it shows two numbers. The left is disk blocks used, the right is the logical size in bytes. For a sparse file, the logical size is big, but the blocks used is much smaller. So then what I'll also do here is I'll do this one. Okay, so basically by doing this, at the start, you saw the A B C D F G H I J, then a long run of 0 bytes the whole, and then you saw the capitals of A B C D F G H I J. Now you can see here is that basically this is a summary of your question 7. Is that I started with f open, f write, f seek, f close. I created a sparse file by seeking forward without writing. ls minus ls shows small physical storage but a large logical size, and then we just did the od minus c, which confirmed the two like the two 10 byte blocks with zeros in between them. So that basically will be the completion of question 7.